So this is example 5 in your book. So we're trying to understand effective annual yield, or sometimes called the effective rate. So remember that the effective rate is the simple interest rate that produces the same amount of money in an account, okay, at the end of 1 year as when the account is subject to compound interest at a stated rate. So we have $4,000 that you're depositing in an account, and it pays 8%. And let me get my arrow here. And, oh, here we go. So $4,000, 8%, and it's compounded. How is it compounded? Monthly. Okay, so monthly, so that means if it's compounded monthly, that really means N is 12. And so we use our compound interest formula. So A equals P, right? So the future value equals the present value, 1 plus R over N to the NT, right? And again, we're just solving for A. So our P, right, our deposit is $4,000. 1 plus our R, which is 0.08, divided by N, and our N is 12. And raised to the NT, so it's raised to the N. Well, what's my N? My N is 12. And it says find the future value after 1 year. So in this case, I mean, this is really 12, right? 12 times 1. So this is not too bad. So we get our calculator, and I'm punching in 0.08 divided by 12, and then I'm adding 1 to it. And so I get 1.0066666667, and that's all to the 12th power. Again, you don't want to write this 12 times, but you're doing this operation first. So in my calculator, I already have this 1.00666 already in there, so I don't want to type it in again, so I just hit the caret symbol, and it should say answer raised to a blank box, and I input 12, and I get, so, oops, 4,000, and then my calculator 1.082999507. Again, I'm writing it down so I can show you what I'm getting on my calculator. But I'm just going to hit times 4,000, and I end up with, so how much money? 4,300. Let's see. Well, 31.998027. Okay, so we want to we want to round to the nearest cent. So we have, well, it's 99, so we can just say 4,332, right, dollars. So that's our future value. After 1 year, this is what is on our account, $4,332. Again, not too shabby. I mean, just for letting it sit there for 12 months, you get a little over $300. So part B asks, use the future value formula for simple interest to determine the effective annual yield. So our future value formula, right, is going to be, let's write this. So we have A equals P1 plus R over N to the NT, right? The same formula we use in 1. But notice that B asks for, it says use this formula, right? This is the future value formula to determine the effective annual yield, right? And it's use a future value formula for simple interest. Well, for simple interest, if it's simple interest, it's compounded, it's 1 year. So we have, our N is 1. So this is really, okay, so for right now we have, right, our N is 1 in this case. because it tells us it's simple interest. Or the, let's see, the future value, right, which is your A. And this really just means 1 plus r to the t, right? So we can, this simplifies to this expression. And we substitute our values. Well, we're trying to find the effective rate or effective annual yield. So we are going to solve for r. So how much did we make? Well, from part A, we have 4,332. We started with 4,000. 1 plus r, which is what we're looking for, and raised to the t. Well, what's our t in this case? So it's just 1, right? So in other words, we have 4,332 equals, right? This 1 doesn't, I mean, we don't have to write it. So we're just really distributing. So 4,000 plus 4,000 r, and then we want to solve for r. So I can subtract, let's see, we can subtract $4,000 from both sides, and that's just 332 equals 4,000 r. And of course, we're dividing by 4,000 because we want to solve for the rate. And notice, right, this is going to be a small number, a small decimal, because the numerator is being divided by a larger number, 4,000. So we have, let's see, move this up a little bit. So in our calculator, we get 0.083, but we want it as a percent, right? So 1, 2, so there's our new decimal. So it's 8.3%. So the effective annual yield or effective rate is 8.3%. So this means that the money invested at 8.3% simple interest earns the same amount in 1 year as if you invested the money at 8% compounded monthly. And another way of another term for this is called the nominal rate, which they do state in your book on page 519. So that is example 5, and I will move on to example 6, the last one.